To begin, I suppose we'll go over like Hello World stuff really quickly again. Those who have a laptop, if you just spin up your Python interpreter, you can easily like spin up Python as an interpreter basically. That's really useful to play with the language, and also if you implement modules, then you can bring your modules in as well and test them directly from the interpreter. So really straightforward, print hello world directly in the interpreter itself. Otherwise, we can easily create a file, for example run.py, and then print hello world in there. Python run.py, and we've got hello world. So two very easy ways of getting to hello world. One thing which I wanted to go over today is actually how to make your scripts executable to the operating system without having to invoke the Python binary directly. And the way you do this is by who's familiar with, like, for example, chmod.
What was it?
Chmod?
Is it a module?
No.
It's command line command.
Yeah, it's command line command, and what it does is that it modifies the permission bits on a file. So if you do like an ls -l on, for example, run.py, on the left hand side you can see that there's a bunch of dashes with R's and W's, etc. The first dash actually tells us if it's like a file, a directory, a symlink. We then have RW dash, and these 3 bits here are the permission bits for the owner of the file. So I'm the owner of the file, Charles, and I'm allowed to read the file, to write to the file, and I'm not allowed to execute the file. Then there are the permission bits for the group. So anyone who's within the staff group is allowed to read the file, but not to write to it, nor to execute it. And other users of the system who are not Shile and who are not part of the staff group are only allowed to read the file as well. So I could say chmod all plus execute of run.py. And now if I do an ls -l, we can now see that everyone's allowed to execute the file. I'll open up the file again, or I could just try running it, but that's not going to work. And the reason why that didn't work is because the operating system doesn't know which interpreter we want to use to run this file. So I'll open up run.py inside Vim again and add what's called a shebang. It's called a shebang because it starts with like a hash and then an exclamation mark. And I'll write user bin Python, because the Python interpreter on my system is basically in the path user bin Python. I'll save this, and I can now directly invoke run.py without having to invoke Python explicitly. Okay? If I rename this to just like run, now I have something that looks like a binary that's called run. If I take a look on my system inside user bin, for example, and I do an ls in there, I'll see like a bunch of binaries that come with my operating system. Okay? If I look inside /bin as well, there's a bunch of binaries in there. So I'll do an ls, yeah.
Can you use these on Windows, these commands?
Yeah, if you install Cygwin, you can. Cygwin.
Cygwin.
Yeah, I'll post it in the comments again, because basically with Cygwin in Windows, you'll be able to spawn up a shell, which will look exactly like this and behave exactly like this. It brings like the whole Unix stack to Windows.
Oh, okay, right.
And a lot of developers who use Windows use Cygwin, so that's the way to go. All my, just speak, Windows speak, all my executable files are here, inside bin and user bin. So what I could do, for example, what I could do, for example, is like move my run inside user bin, and I'll need to invoke sudo. And now, as far as my system is concerned, there's a program on my system that's called run, and I can invoke it from anywhere. Okay. What you could do as well is, and it's probably better, in your home directory you could have like a bin. You could have a bin directory in your home directory, and simply move that run file inside your own bin directory, just to keep things clean. And then add that bin directory inside your path. I don't know if you're aware of like bash RC inside Linux, but basically this gets invoked each time you open up a shell. So inside my bash RC, I have export path equals home directory / bin. That gets added onto the path. So basically I can just call run, and it still thinks that it's inside user bin run. So I'll open a new shell just to refresh my environment, and I'll say run, and it calls hello world. Okay. So now we basically know how to write a Python script that's actually indistinguishable from any other executable or any other program on your operating system.
So what you just did, it's like in Windows adding an environment
Yeah.
variable, yes, so that you can call it directly from your.
Yeah, that's correct. Yeah, in Windows you have to go inside your system settings and look for the environment variables, and you have to add them in there. It's exactly the same thing. Another thing as well, which I wanted to cover today, was how to add arguments to scripts, so that when we call run, we can actually say run and then add something onto there, tag something onto there, like the name of the file, and then we could perform an operation on that file, for example. So let's open bin run, and I am going to use a new command called import, and import sys is basically importing a module which comes with the standard library in Python. Okay, so Python comes along with like a whole bunch of default modules which perform a whole different bunch of things, and that's called the standard library. And one of them is called sys. If I print sys.argv, I now see a list, and the first element in that list is basically the path of the script itself. And if I call run with something like hello.txt, for example, Dipti, you can actually close the door because we've got AC, so we don't want to disturb the door. Yeah, if I call run hello.txt, you can now see that the second item in the list is hello.txt, which is the thing that we're interested in, basically. So let's edit this, and I'll say args equals sys.argv, and let's do some list splicing, which we basically covered last week. So we'll take the arguments that were passed. We won't take the first argument because that's the name of the script, and we'll take all the other arguments until the last one. And now we can say if args print we were given arguments, else we can say print, please provide a file name. Let's run this. I'll just call run. It's a bit confusing, but the first line we see, please provide a file name. If I write that with hello.txt, I see we were given arguments. Okay. I'll remove this. So run hello.txt, we were given arguments. So what we might want to do at this point is say, hey, let's try and work with a file called hello.txt. One thing we may want to do is to make sure that the file actually exists before trying to open it. And for this, we'll import another module that comes with the standard library called OS. And then we'll say if os.path, you'll use path a lot. Path is like a module within OS, exists, and the name of the file that we are interested in is actually name equals args 0. So if name exists, then we'll say print the s exists, and you'll remember substituting strings from last week. Name.
So there is no comma between quotes and name, like we do in C#.
You mean here?
Yeah. No. After the quotation mark, closing quotation mark.
Refer to line numbers.
Line number 12.
Yep.
After here. Yeah.
Yep.
So there is no comma.
Yeah, there's no commas. So basically, this what this percentage symbol does is a bit like when you do a printf in C, and the first argument is the string, and you have the formatting characters in there, and then you have commas, as you said.
Yeah.
And in C# is because it's inspired from C, and then you give the variables, and it pops the variables inside. It substitutes.
That I get it. But
and therefore it's not comma. However, if you had many of them, if I had many of them, I would put brackets around here, name, and then I would put the second one. Like you could put like second substitution, and if that's an integer, I would say I.
Okay. Is that percentage the same as the dot format? Does it work the same
Yeah.
principle?
Yeah. At that point, it's really a matter of taste. Yeah, correct. So yeah, the name of that file exists. Else, I can say print s does not actually exist, and name, and I might exit as well at that point because it's really pointless going any further. Okay, so let's save this. I'll bring the code back up for those who are copying. Run. Oh, sorry, it's not args0, it's actually args1. Attends, let me think. Oh, it's because I didn't actually provide a. That needs to be here. So when I call run, it says please provide a file name, and when I give hello.txt, hello.txt exists because I have a hello.txt. But if I run this again, now it will say, okay, hello.txt does not actually exist. So let's create hello.txt, and we'll make it say hello world. And now when I call run hello.txt, it exists. Okay, good. So we can move on to the next phase, which is actually open up hello.txt and see what's in there. Okay, so let's get rid of this. to open a file in Python, it's ridiculously simple. We simply call the built-in function open with the name of the file, or should I say the path of the file. And then the second argument will say R, which actually means we want to read the data that's in the file. If we wanted to write to the file, we would simply have to put a W. So in this case, we want to read it. We want to get the content of the file. So we'll say content equals f.read. F is really just a file handler. So we're using the file handler to actually call the read function, which reads the data that's inside the file, puts it inside the content variable. And all we're going to do for now is print the content of the file and call run hello.txt, and that bingo prints hello world.
Which library is this read function from? OS or sys?
That's a built-in function.
Okay.
So things that will be used a lot in the language actually get upgraded to being built-in functions as opposed to being part of the standard library, because they just know that you'll use open a lot, and it was just a design decision that they made while coming up with the Python language specification, basically, called PEP.
So, quick sidetrack. What version would you recommend using? 2.7 or 3?
You'll need to use both if you want to get into Python, because at the moment there's lots of code that's being migrated from 2.x to 3.x. So one of the realities of Python is like they didn't make it backward compatible. Therefore, you need to know both, but the differences are not very big.
Right.
So normally, like if there's a difference between Python 2 and 3, I mention it. So far, we haven't really encountered a difference, apart for the print function. In Python 2.x, you can just call the print function like this, whereas in Python 3, you actually have to use the brackets because they turn it into a proper function.
There's division one as well. Division in Python 2.7 is different. You have to, it doesn't give you a flare to have the floating point.
Oh, really?
Is that right?
I'm not
If
sure.
you do 3 divided by 2 in version 2.7, it will give you 1 rather than
Yeah, so that gives you a
you
1,
have to specify the
and you'd have to make that a floating point, get 1.5.
version 3 does it automatically.
Correct. There we go. And that, again, is a great demonstration of why Python is really cool. You can just spin up the interpreter and like try whatever language feature you want to find out, or as we said earlier, testing your own code as well. So let's exit from this. So our run function, our run script rather, opens up hello.txt and prints its content. And now let's actually make it do something a bit more interesting. We'll reverse the content. So we'll say content equals content. We'll access it as a list because strings are also can be manipulated as lists in Python. And again, this is list splicing, so we're going from the start of the list to the end of the list, but we'll step through it backwards with -1. And by calling run hello.txt, it now simply prints out the content backwards, so we could put like a palindrome in there or whatever. And let's rename it, instead of run, we'll just call it like reverse, and reverse hello.txt. This is like a legitimate little script which does one thing, okay? How are we doing? Like, is this really easy and boring, or?
It's really interesting. I like the syntax because I find it really like they have simplified a lot.
Yeah.
It's just to get the string printed in reverse, you have to write a few things. Like in this one, it can do it in a line. So.
Yeah, definitely. And I mean, I'm being like really conservative because I want to do things properly. But if I were just in a rush, for example, I might say dot read, and therefore that would be content. So I've skipped one line. That still works. And then if I were really sloppy, I could actually reverse it here as well.
Yeah.
-1. Now we don't need to do this anymore.
When you say sloppy, is that in terms of reading the code, so or just sticking it all in one line, which you can't bother to?
I'm saying sloppy because it's really hard to do error handling properly if you just have one long line.
Yeah. So you need to have separation so you can just read it, debug it easier.
Yeah, debug it easier, but then also, let's say here we have content equals something. We could say if not content, then you could say print no content in the file, and then exit. Yeah, that's proper housekeeping of your code, because all of a sudden, if there's nothing inside hello.txt, you won't want to go any further, and you'll probably want to notify the user as well. You can't do that error checking if, for example, I take this one step further and just print this. So I said sloppy because, yeah, you can't do your error checking, and number two, the person who'll like open this file will be like, what is this?
Readability.
Yeah, readability, and generally, if you write your code well, you don't need to comment it,
Right.
because when you read the code, it should be self-documenting. Like you see, oh look, he called read, it goes inside a variable called content. So the name of the variable is documenting a code at this point.
Yeah.
This is not self-documenting. Anyone would have to squint at this for, a good solid like 15, 20, 30 seconds. And they'd probably curse your name as well a little bit while doing so. But in terms of the syntax, like it completely allows you to do, really complicated things in one line if you want to as well. There's even like silly obfuscation competitions where people get together to write the most obfuscated code ever. It's really silly, but yeah.
That's fun.
It's fun, so why not?
So are you going to put this on the website? I saw you recording this.
Oh yeah, we're currently recording this, so yeah, I'll take
So
it.
so back to your original. Yes. Then in terms of the speed, it's okay if I can go through it later. Otherwise, it's just like kind of understand it, what you're saying, and then you go say something new, and then I've completely forgotten what you said before, kind of thing. But it's interesting.
Yeah, I mean, it's what we were saying earlier with Dean and Quentin is even if like you don't necessarily catch something. First of all, the video will be available, and number two, like next time you look at it, you'll be like, yeah, this makes perfect sense. So we'll be like flying through stuff quite a lot during the meetups, but then you have the whole week to process it. So, and usually it's just the first exposure that really matters, and then the second time you look at it, it just makes sense. So anyway, good. That's that. Any other questions about this, or we're all good with this?
Yeah.
Cool. All right. So that's our reverse script. What else do we have in store? Yes, sets. Let's spin up Python. Sets in Python allow you to basically have a collection of objects, and the order of the objects doesn't matter, and the objects in those sets have to be unique. So I could have something like, okay, I call set, and set takes an array, and I can have an array with 1, 2, 3, and that's a set, okay? Since all the items are unique, if I have the number 2 showing up in there multiple times, then ultimately we'll only have the 2 showing up once, because everything is unique.
Aren't these called tuples or something like that? Yes?
A tuple is when you just have parentheses
Oh no,
and 1 and 2. That's a tuple.
because I never heard array in Python.
Sorry, the term is list.
Lists
Yeah,
and
the term is list. So depending on which language you come from, you might say array. I have like a C, C++ background, so my mistakes usually make me tend towards those languages. The correct Python terminology is list.
Normally with a set, order doesn't matter.
Order, yeah, so they're unordered. The way that it works internally is like your set goes inside memory, and therefore the order in which you created the set usually means that they will be in that order, but there's no guarantee that that's going to happen. It's not enforced. So yeah, let's so that's a tuple basically. When you just have the parentheses. Tuples are quite useful when, for example, you need to return more than one value from a function. Or when you want to hold like a certain number of things, but you can have many, they could have the same values. They don't have the same constraints as a set or a list. And I don't know if you can actually grow tuples. For example, you don't have any of the kind of extra facilities which you have with proper containers. So we have.
set does. It's... Sorry.
So ask away.
No, the set. What does it do?
What does it do?
What does it do? Yes.
With sets, we can, for example, check if one set is a superset of another set. Okay, so this comes from set theory. Let's have another set with 2, 3, and 4. Well, actually, let's start with the same set, because sets are their own supersets and sets are their own subsets. So if I use the subset operator, that's also going to be true. Now let's check if 1, 2, 3, 4 is a superset of 1, 2, 3, which it is. And if it's a subset, and no, it's not. To be explicit, we can add the 4 here. Is 1, 2, 3 a subset of 1, 2, 3, 4? And yes, it is. And is it a superset of 1, 2, 3, 4? And no, it isn't. We can also do the intersection of two sets. So we have 1, 2, 3 and 2, 3, 4. So the intersection of these two sets should be 2 and 3, right? Right. So that's a new set that contains 2 and 3. This is
Does
particularly
it create that set?
Yeah.
Or just...
Yeah.
Okay.
that actually returns a new set. And then we can perform the union between these two sets as well. 1, 2, 3, 4. This is really probably more pertinent to you if like you're involved in numerical stuff, I guess.
Will it work on text arrays and strings as well?
Yeah.
That's
Any-
brilliant.
Anything that's comparable, basically. Yeah.
This
and-
takes so much work out of the code, honestly.
Yeah.
Because I'm thinking from what I do.
Yeah.
What was your question? Did you say text strings?
So instead of using numbers 1, 2, 3, if I use words, then I can, for example, if I'm searching a string in a file. So basically, what shell can read a few lines into a set, and I can say that does this string exist in that set of lines.
Right.
So
Yeah.
if it is part of that, if it is a subset of that superset, then it'll tell me that. Okay,
It'll show
yeah,
that
it
that
is
it
true.
exists.
Yeah,
in that.
yeah.
Right. Okay.
Yeah, that's easy.
Oh, sorry, I work more on database and data, so my question.
Sure. Yeah.
I
yeah.
think of my problems.
Well, it's interesting
Yeah.
hearing all from different people's
Yeah.
perspectives. So.
Yeah, completely. I mean, in that script where we load the hello.txt file, the inside the content the content variable, if you remember, we can just call like a dot split on there with the new line separator, and that gives us an array that contains all the lines inside that file. So you could easily read one file, split it on the new lines, and then each line is inside a set, basically.
What's dot split? Is that a function?
Yeah,
of
it's
Python?
yeah. I mean, I can show you if you want. And then you'd be able to perform set operations on the content of two separate files. So I mean, I'm more than happy to do it, but
Doesn't Python read the whole file as a single string?
Yeah.
With all the spaces and all the return carriage returns.
yeah, sure it does. So okay, look, we can just do content equals open hello.txt. Sorry, actually that's the handler. So I'll say this dot read. Okay, and now content contains hello world. I'll just spin up a new thing here. I'll open up hello world and I'll say foo bar and baz. Okay, so that's hello.txt, and then I'll have vim world.txt, and that will contain baz, bar, and span. So let's go back here. Content now contains foo bar and baz, and let's call split with the new line character, and our content contains this array with the empty one at the end, which we can get rid of by calling trim. Sorry, not trim. I think it's called. I'm getting my languages confused. Anyway, so let's just have the empty one in there. It's fine. Then we could have actually have this as a set. And then we could have content 1, which contains the other one, and then we could say content intersection with content 1, and now we're basically performing set operations on the contents of these various files.
Really?
The other thing, the other operation which we can do is a symmetrical difference. So basically, items in the sets that exist in both sets, in this case 2 and 3, are not present with the symmetrical difference. However, items which are only present in one set end up in the result, which is why we have 1 and 4. Also, in terms of making this a bit more useful, instead of saying C equals like the intersection of this set with the intersection of that set, you could say let's have a variable called A, and that's set 1, 2, and 3. And then we could say B is equals the intersection of I'll say A is equals to the intersection of itself with the set 2, 3, and 4. Does that make sense?
No.
Nope. No problem. Okay, so on this line here, we're declaring a variable that contains a set
Yeah.
with 1, 2, and 3 in there. And here, what we're saying, this is the exact same thing as saying A equals the intersection of A with the set 2, 3, and 4. So basically, what is this? Okay.
What's intersection? Same. What's
So
the same
basically,
as?
we're performing the intersection of the set A with this set here,
Right.
and we're assigning the result onto A. And all this does is that it's the same thing It's just the syntax is a bit more condensed.
Does it add something to A then?
Yeah, basically
Does it add the
it runs this
for-
set intersection, and it assigns the result onto A. So these
so A ends up 1, 2, 3, 4.
A ends up 2, 3 because it's the intersection of itself with the other set.
Oh, okay. What's
It's a bit like
okay.
it's a bit like when you say if A equals 3, and then you say A equals 3 times 2. So A is now equal to 6. Or you could simply say A times equals 2, and now it's also equals to 6. So this expression here, sorry, that wasn't correct. I meant to say if A is equals to 3, and you say A equals A times 2, now A is equals to 6. Yeah.
Right, okay.
And now if you say A equals 3, and then A times equals 2, that's exactly the same thing.
So it is basically saying the same thing. It is just that
You type this.
call it a gimmick. It just shows you the operator. So basically, it performs
There's a
the
word
function
for it,
first
isn't
and
there?
then.
There's a word for it. It's the same as when you do like plus equals 1. and things
Yeah,
like
so
that.
it's the same as plus equals 1. I think you can call it like an in-place arithmetic operator. But maybe I'm making things up.
I can't remember what the word is. There is something, a word for it. But
I'm sure it's useful, whatever it is.
Is that in other languages as well?
I'm hoping.
I saw the same in AutoCode.
It's a
It's
common thing.
It's in all the languages, and normally it has to do with optimizations as well. But I mean, optimizations can happen like at the compilation phase. They can happen at the language
Right, okay.
phase as well. Python is actually not at all optimized. Later on in the course, we'll start delving inside the virtual machine, and you'll see that Python is not at all optimized.
So that's how fast it runs.
Yeah,
in
for
real
example,
time.
yeah.
Okay.
Yeah. Okay, so
We were doing sets.
Sorry.
we're actually done with sets. Yeah.
Alright.
Nearly.
No, I just wanted to ask, what happens if I don't put a slash and in split? Does it split it like each letter, or?
Space is a default token for splitting.
Okay.
So you can say foo bar baz dot split, and now you end up with a list that contains foo bar and baz, and that can be multiple spaces as well.
So this for strings, it takes both double quotes and single quotes.
There's no difference off the top of my head. I don't think there's a difference.
And what's the difference? Is that split? It's put the commas in. Is it? You've had foo bar baz.
That created a list. So split takes a string,
Yeah.
and it runs through the content of that string,
Okay.
looking for the token, and it basically
and the token's
returns a
what?
list.
The space.
Yeah, so the default token is
And then it
space.
just puts a comma in there, which
That
defines
that's a list. So if I
defines it as a list. Okay,
yeah, so if I run type on this, it will tell you that's actually a list or an array.
That's because of the dot split.
Huh?
That's because of the dot split.
That's the dot
function.
split that
Yeah,
turns a
it
string
turns
into a
list.
yeah.
Okay.
Yeah. Switch this off. Anything else? We're done with sets.
You said it's got space by default. Can you change that to another character to make it into a?
Yeah, of course. So
Or is that just inside?
of course, yeah, correct, yeah. So you just have to put it as the first argument of split, and now we're splitting it by a dash.
So you need to put it as a string inside there. You have to have the speech one.
dash inside the speech marks.
No,
Yeah.
this, yeah.
So it splits at the dash. You can't just put the dash without the speech marks.
No, because what is this? What's a dash? I mean, a dash is like an arithmetic operator. If the thing that's on the right and on the left of it support having a minus in between them, such as if it's an integer, for example, or if it's sets, for example, then yeah, you can use minus. But otherwise, what's a minus?
Right, brilliant.
Whereas here, by putting it inside the quotation marks, that's actually a string. So we're passing this string that contains only a dash as an argument to the split member function, which is part of the str class.
But does it only apply, split only apply to strings? So I think I tried using it on a list and I didn't like it.
No, I wouldn't know. What you can do, however, is called join on a list. So this creates a list, and let's do it two ways. I'll say A equals now a list that contains foo, bar, and baz, and let's add a dot in here, for example. I'll say dot join, and I'll give it a list, which is A, and now that rejoins these things with a dot. Does that make sense?
Oh, yeah.
So a string has got a split function and it's got a join function as well
to put it back together.
to put it back together. So you could even do it as a one-liner.
So when you split it, you got a list, did you?
Yeah,
And then you rejoined it to a string with the join.
Yeah.
Fine.
and you could do it as a one-liner as well. But again, one-liners look a bit confusing. So I'll say join this. Oops, what have I done? There we go. So as one line, we've turned something that was separated with dashes into something that's separated with dots.
So the foo dash bar dash baz doesn't exist anymore. It now only exists as foo dot bar dot.
Yeah, definitely, because I didn't assign it to a variable. It's just within that one-liner, so it no longer exists. It existed for like a brief moment while these operations were taking place, but it's not stored anywhere anymore. At least not anywhere that's accessible.
I mean, it seems like a really powerful function. I mean, in the past, I've been, trying to convert CSVs to into importing it into Excels and stuff like that, where it doesn't import the way you want it to. It looks like you can just pretty much do anything with it.
Yeah.
It's not this sort of thing. You just run it and then you get it in the format that you want to.
Yeah, definitely. I mean, Python is really powerful for string manipulation. For string manipulation, what's even better is Perl, which actually stands for Practical Extraction and Report Language. And Perl, initially, when they designed it, it was specifically for dealing with tabular data inside text files or CSV files.
Oh, yeah.
So they have lots of stuff that's built in for manipulating text files and stuff, but Python is equally good, definitely. Okay, so that's that. Let's see what else we have. Imports. Okay. Is everyone okay, or do you want a break or something? You good? You good to plow on? Cool. All right. Yes, imports. So I'll create a folder called my. Should I call it my module? I'll just call it imports for now. So I'm not working out of my home directory, and I'll create a folder called my module, and I'll create. Let's have two terminals just to make it a bit easier. Okay. and I'll create a file called run.py. And I'll create a directory called my module if I haven't already. Yes, I have. I'll go inside my module and I'll create a Python file in there. I'll call it hello.py. And hello.py is just going to print hello world once again. And let's go back up one directory, the place where we had run.py. Okay, and I'll say import. Actually, I'll say from my module import hello. Okay, makes sense. And that should run, right? But it doesn't run. And the reason why it doesn't run is because Python wants to have a file in there called init.py to actually recognize this folder as a folder which contains Python modules. Okay, so I'll just create init.py. So now inside my module I have init.py and hello.py, and now I'll call run.py, and all of a sudden, as per magic, it works. So when I call from my module import hello, it actually automatically executes the init.py, and we can see that happening if we open up init.py and we say print executing init. I'll say executing init. Okay. Run.py, it says executing init, even though explicitly, you know, I haven't said anything like import init or whatever.
So what does it use init for? Just as a flag to understand this is a directory which has the files, or what?
It's a Python convention, and it's actually quite useful. The reason why it's useful is because normally the way that you actually go about doing this is, oh, by the way, the .pyc files contain the bytecode. So I was chatting with Quentin earlier, and the Python binary does things in multiple passes. The first pass was the compilation. It actually reads through a code line by line, and the output is bytecode, and it stores those as .pyc files. And then the second phase is actually reading the bytecode, and that's where the interpreter kicks in.
And what is bytecode? I've never heard that term before.
It's literally zeros and ones.
Oh, really? It's like assembler.
No, it's literally zeros and ones. It's just that Python knows what to do with these zeros and ones. If you look inside the Python source code,
And that's effectively that's compiled. That's compiled code that's going to run that bytecode.
It's not compiled. It's not compiled. No. So the interpreter, the Python interpreter, opens up these .pyc files, or they're already in memory, and the zeros and ones actually will add up to 256, and there's like 256 opcodes in Python.
Right.
So the value of each one of those bytes is actually one opcode, which ends up being one instruction.
Yeah.
And that's the interpretation, and ultimately the third phase is running that code in the Python virtual machine. And we, if we stick with this, which I have every intention to, towards the end of the Python track, we'll be delving inside the virtual machine, and we'll get very comfortable with understanding also what's happening internally with Python, so that when we're writing our code, we sort of understand what's going on. Yeah, so I'll just delete these things for now. Star.pyc, and I'll move this. So now all we have is our init.py, and our init.py contains hello world. Okay. One of the advantages of doing this, vim run, is that you could just say import my module. So you wouldn't have to say from my module import that file, that module, yeah? we actually have a directory that contains an init.py, and then we can say, well, I don't have a function in there, but let's say my module init, let's have a function called func. Let's open up run.py and say my module.func. That calls hello world. Okay. Now let's go back inside my module and let's have a file called hello functions or whatever. Vim hello functions, and then def say hi. Okay. I'll open up init and I'll say from hello functions import star. So everything that's within the hello functions module now gets imported directly within the namespace of my init.py, which is actually sort of the main file inside my module that gets executed automatically. And therefore, from hello functions, import star brings whatever's inside hello functions and puts it kind of on the same level in terms of the namespace. So if I go back into my run.py, I should just be able to say, unless I made a mistake, my module dot, can you remember what it was called? Say hi or something?
Yeah.
More hello functions, say hi. There you go. Does that make sense? Sort of?
So yeah.
Okay. I think it will make more and more sense the more we start adding code to this module, why this is useful. Let's go inside my module and add another file, and let's call it by functions. Touch by functions.py. Okay? Vim by functions, and then def say by, print saying bye, vim init, and then I can say from by functions import star, Python vim run, and then I can say my module dot say by. Run this. Okay. Hello world, say hi, say bye.
Yeah.
So
Can you open up run.py?
sure.
Alright.
So what's useful here is that I'm actually putting code inside various files, which is an organized way of writing your code, because you don't want to have more than a few 50, like 100 lines, or like I don't know, max 1,000 lines in each Python file. So saving your code in different files is a nice way of organizing things. Generally, there's a rule of 7, which is the average human being has trouble remembering more than 7 items in front of him, and therefore, like you could have, let's say, 7 functions inside one file, or you could have a class that has 7 member functions in there. Or you could have 7 files inside one directory, and then you would say, okay, I'll create a new directory and I'll have like another 7 files in there. So it's a nice way of kind of organizing your code in a way that's easy to remember, easy to understand, and easy to work with. And yet, from the point of view of the client, my run.py, which is using the module that I've just created, I just have something called my module, and I can call func, I can call say hi, and I can call say bye, because I've done the extra homework of deciding how these things were going to be available to the client of the module inside the init.py file. but that doesn't stop me from just opening up run.py and forget about all of this. I'll just say from my module import hi functions, and then hi functions dot say hi, and I must have made a mistake. Hello functions. This says hi. So in this case, what I've done is that first of all, when I say from my module import hello functions, this still runs the init.py implicitly. It executes it implicitly.
Right.
But I actually went in there and I reached for the hello functions modules directly, because I, as a user of this particular module, I know that that's the class that I want to work with directly.
Right.
So we have a mechanism which gives you convenience, but it gives you granularity as well. The init.py gives you the convenience, but the ability of just pulling out the individual modules within that directory is what gives you the granularity. So if you're writing a module that has multiple modules in there, multiple classes, and so on and so forth, you have this kind of mechanism that allows you to, in a very granular way, go and pick out exactly the class that you're after.
Can we compare it somehow with events, like when you import your module, this event will trigger this code, so it's
Yeah, definitely. I mean, inside your init.py, you're completely allowed to do whatever you want.
it's the same. You can do the same things you do in a regular file you create, like code in Python, but it would work every time you trigger your module, you import your module.
Absolutely, yes. So, for example, I mean, recently I worked with I wrote this Python module, which actually uses an executable, like a binary file that has to be downloaded from the internet. And in the import, like I actually do the downloading. So the first time that the user starts using the library, it downloads like this thing in the background and then starts using it, which is quite naughty as well. I mean, in terms of security, it's just awful. In terms of security, it's just terrible. But yeah, you can just run whatever you want, even though all the user's doing is typing import. You can download the whole internet in the background. So that's the import mechanism in Python. Any other questions about imports, or?
Is there a way to import if I have called them in an ordered way? I want to import just a set that starts with the same letter, or with
No.
Okay.
No, there's no.
Somebody's phone?
It's not me.
Sorry. I think you can, because internally the import mechanisms in Python are inside modules, and I'm sure that there's ways of doing exactly that functionality, and you'll find that very easily inside the docs, or you could even implement your own. But why implement it? Because it's there for sure. With the default behavior of just writing imports and the name of the module, that's not going to happen. But I can guarantee you that in the background there's a function that you can actually give it like a string with a star and whatever, and it will do what you expect. And that's I mean, the standard library that comes along with Python is really just a bunch of Python files. So you could easily open them up, or you can, as we did right there, you can just go and import exactly what you need and make it do exactly what you want. So you can dig inside the internals of Python very easily. Anything else about imports?
So all these modules, they're not Python developers themselves, like who invented the language. It's people who write these modules in other languages.
Okay.
or
So
it's-
that's actually packages, which was what I
it's
was
the
going.
same as module, isn't it? Because you import it from internet, you download it, and you import it as a module and use it as a standard Python library, isn't it?
Correct. That's absolutely correct. So if you go on PyPy, like pypi.python.org, this is the central repository that contains all of the Python, but they refer to as packages. And the other day, like it actually went over 100,000. And yes, there was like I actually started a thread on the internet. I was like, yeah, it's going to go over 100,000, and everyone celebrated. It was ridiculous. So yeah, there's 100,000 packages in there. So there's all the functionality that you could ever dream of.
Who does develop these packages and in which language?
Anyone can add to PyPy. All you have to do is create an account. So if you click on register,
Is it like an API?
the term API is so vague in my
Yeah.
mind that I'll say yes, because everything is kind of an API. But if you click register, you can just like register, and then there's mechanisms where you can basically push your code onto PyPy, and everyone can use it.
And then you can do a hidden init module.
You can be as naughty as you want, and you might get away with it. But you know, these are security flaws which also exist in like.
So nobody double checks the security like of the code which is posted and for the use of others.
Yeah, no one checks. I mean, it's the same with npm in Node. Basically, there's like a bazillion. There's a bazillion packages on npm as well, and some packages on there are really fundamental, and they get used by like hundreds of thousands of different JavaScript-based websites. And one guy pushed like a silly thing inside this Node module, and all the people who were using that module, like the systems automatically updated to the latest version, and like half the internet went down for half a day until they found out like, oh yeah, someone pushed the wrong thing in that module. So,
Did they hire that person or did they fire?
there's no one to hire and there's no one to fire because since this is more like an open source type of thing, yeah, what are you going to do? So all these
really
systems.
dangerous, right?
It's best to just write what you've got from
Yes.
scratch
Sure,
rather than
but you'll never get anything done.
yeah.
But
you need to.
if you can convince someone to, pay you
Download
money,
it on
and
their machine first.
Yeah, it's not easy.
if you're working in like an ultra secure environment, then there might be restrictions in your work environment, such as hey, you can't bring anything from, or like these are the packages which you're allowed to use, and these like you can't use anything else. That's completely realistic.
Is there some that are sort of reputable, or are they all just come with a warning? Just
That would depend. That would completely depend on like the things that the security department in your particular organization agrees upon. I know that the more you go inside like banking sectors, the more strict they are. And if you're writing code for banking, I don't think you can just bring in any npm package or any Python package. They won't let you do that. Your workstation probably won't even have access to it.
Exactly.
Super restricted.
Even the USB port, so to say.
Yeah,
Anything.
nothing. Like it's just hermetic. Whereas in other industries, just no problem because they don't necessarily have the same security policies. normally, I mean, you wouldn't sort of go directly on PyPy. You would use Google. So I would say Python package to pretty print dir. And it's not pprint, although pprint is quite useful. I won't go over it now. I'm interested by pdir, and I don't know if you saw earlier, but if I say if I have a set, for example, with 1, 2, and 3, I can call dir on it, and dir actually shows me everything that's within that object. But as you can tell, it's a mess. All right. So I don't want to see this mess, and I know that there's this package called pdir. Dir is a very useful utility function in Python for developers and debuggers, but basically blah blah blah, it doesn't look good, so this one actually makes it look good. So I want to use pdir. So I'll say pip install pdir, I want pdir2, and I'll say -- user, because I like installing packages inside my user directory, so I can just ditch them easily and sort of make the difference between what's there installed centrally and what's installed in my home directory. And this downloads it from the internet, from PyPy basically, and installs it. I already have it installed, so, and I have it installed inside this directory, which is basically inside my home directory, inside library, Python 2.7 lib, Python site packages. I've got like a whole bunch of packages in there. I'll remove pdir. I'll go back to where we were earlier. I'll say Python import pdir. See, that's no longer there. So I'll go back and I'll say Python install pdir2 inside my user directory. That actually downloads it and installs it. So I can say Python import pdir, and now it's available. I can say pdir a set, and now it's a lot prettier. I can actually see what are like the arithmetic methods, emulating containers, whatever that means, you know, pickle or like ridge comparisons, etc. Functions, like this is actually.
Is the whole help directory?
It's different because help. If you say help set, that's also the same sort of way of. There's just two ways of doing the same thing. Help actually allows you to kind of scroll through it as well, and you will see differences between like what's inside help and what's inside dir. I don't know if you can actually call help on an object. Yeah, you can. So it's the same difference. I was actually like showing pdir as an example of downloading a package from PyPy, but it's a valid question. What's the difference between help and dir? Let me know next week. But yeah, that's really like that's all it is, installing packages, and quite often packages might bring in some other packages, or they might compile some code as well. So when you download some packages using pip, you might see like it starts compiling like 100 sort of C++ files, because that's also absolutely valid in Python. Okay, what else? So does that answer your question between like difference between a module and a package and so on?
Well, modules are written in Python, and packages.
Python as well.
Do you
It's
think
just
written
that
in C?
it's yeah, sure.
The Python itself, is it written in C?
CPython is written in C.
Oh, C Python.
Yeah. So the default implementation of Python on your system, 99.9% chances that it's going to be CPython. But there's different and that's basically Python implemented in C. But Python at the end of the day is a language. So like Python's been implemented in Python, and that's also called PyPy, and it actually runs a lot faster than Python. There's, I can't remember them off the top of my head. One of them is implemented in JavaScript, so it runs within browsers. Python's been implemented in Go. I can't remember what that's called. Whatever it's called. So yeah, Python's been implemented in a whole bunch of languages.
It's the one that's like IronPy or something.
Hmm?
It's the one like IronPy or something. IronPy.
How do you spell that?
IronPython. IRON.
Maybe. What is?
I don't know. I'm asking. That's what it sounded like I saw.
Yeah. I haven't heard of it, but
Seems to be a lot.
But does that answer your question about like modules and packages? Basically, like your modules are implemented in Python, and they can contain some C in there as well. If I can show you actually,
It's an implementation targeting the .NET framework and Mono.
wow, cool, nice.
If that means anything.
This is a Python module that I implemented, and I maintain it like on a kind of open source basis, and that's got a setup.py, and in the setup.py I describe basically how, like where this is where the Git repository is. The download URL is like I mentioned earlier, like I can download a binary file, etc. These are the keywords that show up inside PyPy. So I'm basically describing like extra package data, such as the PEM file for the HTTPS server, and that later on goes inside PyPy. So if I look for hoverpy,
So you created your own web package.
yeah. So this is like one of my own packages, and anyone is completely free to do this. I mean, that's exactly what it's for.
What does it do?
It basically caches your requests. So if you have some Python code that makes lots of requests from like other dependencies, other servers, and downloads lots of data, as is the case a lot these days when you write code, like you depend on lots of different services. If a service goes down, if it's not available anymore, you can't do your work.
Yeah.
And one way to deal with this issue is called service virtualization. Basically, you record all of the HTTP traffic happening, and you save it inside a database. And then you can read the database and sort of play that information back. So as a developer, the service that you're using could be down, but you wouldn't care because you kind of cached all that data. And you could then start modifying the data, playing around with it, like injecting failure, and come up with code that's more resilient. So if you go at hoverpy.io, this is like the documentation for hoverpy, and you have some examples of using it there, etc. So you can use a Python decorator. We'll go over Python decorators. This would capture your request, and then you can simulate your request. And at this point, you can be offline, and it wouldn't matter. Okay, so what else? More. Classes. All right. So someone asked me if Python is in object-oriented language, and it can be in, like it has object orientation built into it. Basically, it supports classes. I don't know if you've seen this, but like object-oriented programming is coming under fire at the moment. So years ago, people said, "Oh yeah, object-oriented code is the best code that there is, and all you can do is write object-oriented code." And now people are starting to say, "Well, no, actually, like functional code is the best, and object-oriented
Really?
code is rubbish." Yeah.
God.
Just elaborate on the difference.
Sorry?
Okay, the difference between the two.
There's a big difference.
No, can you tell me, elaborate on what the difference is between the two?
Sure. I'll kind of okay. I'll try and summarize it. With object-oriented code, you basically use classes a lot. So with a class, for example, I'll take you through this example, which is always used when describing object-oriented code in Python. Like you have a class called animal, and then you have a class called cat, and you have a class called dog. And the cat inherits of the animal, because classes really have to do with like I don't know what you call them, phenotypes or something. Basically, like a cat is a type of animal and a dog is a kind of animal, and then you may
A
have
hierarchy.
It's a superclass. again.
yeah, exactly. So like that's one way of writing code, because that's sort of one way that we like to think about things. But it has its downfalls as well. Namely, like if you have an animal, and then you have a cat, and then you have like a different kind of cat, and then you have a different kind of cat that can meow in a special way or whatever, you start having these big hierarchies of classes all inheriting of each other. And after a while, it becomes really hard to reason about like big hierarchical structures inside your code. Yeah. So it sounded like a good idea, but in practice, it's not. With functional code, you basically don't really use classes that much. Another thing about classes as well is that you store lots of data within your objects, and you modify that data in your classes. Since, like in functional programming, you try not to use classes that much, or if you do, you sort of copy all the data and you just send back lots of copies of your data. You wouldn't necessarily use for loops. Like it's a bit difficult to explain unless like you actually go through like writing code in an object-oriented way, writing stuff that's a bit more functional, and then compare them. Yeah, does that make sense? More or less?
Little, yeah.
A little, okay.
Because I'm a beginner, so it took me ages to just like, the hierarchy, just to
Right.
just grasp the concept a little bit on the classes side. But yeah, obviously with time.
So Python's not object orientated; it's functional. Is that
It can do both.
Oh, okay.
It can do both. I'll show you, for example, like map and filter in Python. These are like really typical sort of ways of working in a functional way, whereas using classes and iterating through objects are very object-oriented ways of doing things. I'll delve into like object orientation now. I think it's a bit early to look inside map, filter, and lambdas and stuff because that's more advanced. But the distinction will become really clear.
Can we just have a 5-minute break?
Sure. Yeah, of course. Do you want the fob?
Oh, if it's if we can get back in.
So yeah, classes very briefly. Oh, okay, good. Well, I'll just use the. No, come on, we can actually do this. Okay, let's do this real quick. So yeah, the example which I mentioned earlier with the animals, I'll have a class called animal, and it inherits off something called object. An object was added in Python 2.2 to basically allow to inherit off Python classes that were implemented inside Python modules that were implemented in C. So you don't really have to worry about it for now, but just remember that when you create a class in Python, you have to inherit off object to have what's called a new style class.
That is the syntax of inheritance.
Sorry?
That is the syntax of inheritance.
That is the
brackets.
syntax of, yeah,
You
exactly.
don't have things like extends or any of that sort of stuff.
No. So in Python 2.x, well 2.2 to 2.2 to 2.3, but not inclusive of 3. This is called like an old style class.
Yeah.
And this is called animal object. This is called a new style class. Okay. Whereas in Python 3, this is a new style class, and this is also a new style class that's just a bit more explicit. So there's actually that difference in between Python 2 and Python 3. Therefore, explicit is always best. Just add objects in there. In a class in Python, you have an init function which takes self, and self is the current object that we are working with. If you've worked with C++, it's the same as this, but you actually have to pass it as the first argument of all the functions, of all the member methods inside a class. And I'll just print initialization, fine, initialization. And now I'll have an object called A, or variable called A, whatever. And I'll invoke, I'll create an object of type animal. Okay? And I'll open another shell. And say Python, whatever it was called, run. And that says initialization because the init function gets called when we create a new object of type animal. And I'll add another method as well called speak, which, like all methods, takes self. And I'll say print not implemented. And I say not implemented because I want to inherit off animal, and I want speak to be like a virtual function. So like I don't want to be able to call it. There's actually things that you can do in Python to like explicitly say like this is a pure virtual function, etc. But we won't get into that yet. And I'll also have something called class cat, and that inherits from animal. And my cat will have a speak as well, and that says meow. Meow. And I'll copy and paste this. And I'll have a dog. And if your dog says meow, you're in trouble, so and I'll have an array called animals. Sorry, a list called animals, and that contains capital D. That contains a cat object, contains a dog object, and it contains an animal as well. Yeah, makes sense?
Mm-hmm. Yeah.
And I'll say for A in animals, print, do I need to do that? What am I doing? I'll say A.speak. Save this, Python, run. So the init function in the base class was called
Twice.
every time we created a new object, because dog inherits from animal, and therefore the init function was called. And like same thing for cat, and then we constructed an animal directly. However, when we called speak on a cat and a dog, it saw that the speak member function was actually implemented inside the cat and the dog, and therefore it called those instead of calling the speak that was implemented inside the animal.
So you implement the init function when you define only your base class.
Come again?
So you define the init function only when you define your base class.
No, you can actually have some special kind of initialization inside your objects as well. So you can say def init self, and then you could say
Yeah, assign some variable or whatever, initialize something.
of cat. But now what will happen is that the initialization of your animal won't get called. Okay.
Yeah, because it has its own.
So if you have some special kind of things happening inside the init function of your animal, like you're setting some important data, then that won't get called.
So what if you don't have your init function in your animal class? So will it go back to its object class?
If you don't have def, like if you don't have this inside animal,
Yeah.
then it just won't get called. So the init function is like, it's implicit, basically. You don't actually have to define init. The class knows how to initialize itself. Defining init just allows you to kind of do whatever initialization you actually want to do.
Do you ever not have any initialization in a class?
Yeah, sure.
Is that a common?
I wouldn't say it's common, but you can.
But
Like, you need to wonder why you're doing this, because the point of a class, I'll show you, is, for example, I'm going to add some data on this class called name. So I'll say self.name equals, and inside init, I'll allow you to give the name of the animal, okay? So let's remove this for now. So self.name equals name. I'll remove initialization and speak. Yeah, I'll keep not implemented. So what's happening now is that inside init, I can put the name of the animal. So a cat can be called, what's the typical name for a cat?
Tommy.
Tommy. Yeah, that makes sense. Dog could be called, Harry or whatever. Rover. And animal, that wouldn't really have a name, so we would just.
Python.
Yeah. Okay. We can call it Python. That's fine.
I'm not getting why you put animal there. Why not just have cat and dog?
That's a very good question. And also another good question is why would we give it a name? Because basically, the point of animal here is that it's abstract. So I could even prevent you from calling speak. I could say, like, assert false. That will actually break things when we run it. And that's the kind of behavior that we actually want. So I'm saying you're not allowed to call speak, because animal is only there for you to inherit from it. I'm not really allowing you to use that code explicitly. I want you to inherit from it. So this would make a lot more sense. So we still get meow and woof, but we could say, like, the name of the animal. S says meow, and that's self.name. And S says woof, and that's also self.name. Now when we run this, we have Tommy says meow, and Rover says woof. And to answer your question, Joel, you see the init function is there because we're giving the name of the animal as we actually create it, and we store the name of the animal on a member variable called self.name, which we then use inside one of the member functions. So typically, if you create an object is because you want to kind of hide away the fact that like you have an object and it has different attributes. So for example, we're like of class people, and we have a name as well, but we also, have like a height, for example, and we have a gender, etc. So why would you want a class if you're not going to have data that comes along with it? Because that's the whole point. And if you want to have data that comes along with it, you would need to have an init function.
Would you like to have a class in the first place? I never used classes. I'm just curious.
You don't have to. It's because people like to think with classes. If someone said, hey, let's have object-oriented programming, I think it's a great way of writing code because it emulates how things work in the real world, kind of.
So it's just giving names to things and then
Making it an
It's like having
object.
templates, isn't it?
Not really, it's just thinking about objects. So like we are
Yeah.
instances.
Yeah, like for example, passport is an object, and then within it, the fields can be attributes, right?
Well, like your
The
picture,
same-
your name, your
Yeah,
address.
so-
and so
Yeah,
forth.
exactly.
That
So,
would be,
then
so
you have-
exactly, yeah. So like you'll have something called, book or whatever, and then that can have like like a class called passport, and that inherits from book or whatever you want to call it, and then you could create an instance of passport, and the fields in there would be
Yeah.
member variables. So it's like that's how we think. Or like if I see you in front of me, like I'm thinking of you as a kind of instance of like a human being or whatever, and therefore that way of thinking went into the way that we write software.
Is that to compartmentalise things so
Correct.
we can reach different parts when we need to? So is that what class is? Different classes within a class or within an object. So when we need to call on that object, a specific one, we can reach it basically. Is that object oriented?
Absolutely. So you could have inside speak. You could have like 1,000 lines of code here. Like you could set up like a whole bunch of complicated variables. You could do like a whole bunch of math or whatever, and then print out the result there. And the fact that you're hiding all that complexity inside one method, you could call it like encapsulation. You're encapsulating encapsulation and abstraction. So you're hiding away that complex functionality within just one function. The problem with object-oriented programming comes from the fact that like here we only have self.name, but let's say we also have like the the gender of the cat, and we also have like another, like all these different properties, okay? And then we've got like someone is a bit sloppy and they wrote like 50 different functions that you can do on an animal or on a cat or whatever. It becomes really messy and it becomes really hard to work with because you have lots of side effects. And what side effects mean is like you call the function walk and 5 of those member variables changed. Like the walk function changed like 5 of them. And there's a bug that happens in your code, and you're the guy who has to step through the code and understand what methods are editing what member variables, basically. And side effects are hard to track while you're debugging. So one of the aims of functional programming is to reduce side effects. That's why I mentioned like you pass copies of data. You wouldn't necessarily store the data on site in objects, because that's a very object-oriented way of doing things.
What happens with private and public and getters and setters?
You do have those in Python. Not a lot of people actually use them. You could say underscore name equals name, and then I haven't done this in a while, by the way, using like properties and setters and getters and stuff, but just because you don't have to.
Because it's open source, you don't need to give other people to work. You can give other people to work with the entire code, like to see where the problem is if you're debugging it, something doesn't work well. As you say, if you do these properties and get and let and set and much harder to see where the problems is.
I think in open source, like you'll actually find that people are quite strict. So if you're working on an open source project, someone might say you can use properties or we don't use properties.
Also, people do use properties.
Yeah, I would think so. Yeah, on open source projects, you'll probably find much better, higher quality source code than you would find in a private organization when it comes to Python. And one of the reasons for this is that normally Python in companies is really only used as like a way of gluing things together. It's quite unusual to find really large code bases, like really large Python code bases inside companies. Normally they'll use like a whole bunch of open source, and you'll only find like small Python scripts or like 100 lines there, 1,000 lines there, etc. And since it's not really mission critical in organizations, they tend not to have very strict, strict guidelines in terms of how to write it. Whereas when it comes to C++, you'll usually find some really strict style guidelines. So it's nearly 8:30. Yeah, I mean one last thing is like if you did have an init function here, because you wanted your cat to have like a special kind of fur, you could have self.fur equals fur. Although you'd have to kind of pass the name and the fur as well. And the problem here is that your cat will no longer have a name. And let's say he has like long fur. Oh, and sorry, I started doing your getters and setters and I didn't finish. You'll need to look at what's called something that's called property. I'll do it in the future, but honestly, that's like more advanced stuff. Don't worry about it. If I were you, I wouldn't worry about it. Cat object has no attribute name. What line is this? Line 15. Self.name. Okay, so it doesn't have a name because now the init function was called here, and therefore that's shadowing the init function of animal. So you can actually call the init function of the base class as well with super and then cat self.init. I always forget the syntax for super, and then I think that takes self. I forget it because it's horrible. Dog has no underscore name. And oh, sorry, that's actually the name that we need to pass here, not self. Okay, so we're back to where we were. Cat now has an init function that takes self, it takes name, and it takes fur. We set the member variable fur with the fur that was passed in, and then we call the init function on the base class, and we give it the name, and that sets the name for the animal. And we now have like an enhanced cat, so we can say says meow with s fur, and here we can say whoops self.fur. There we go. Tommy says meow with long fur, and Rover says woof. So now we have the advantage of being able to use a base class to do some of the common work that's common between our different children classes, and we can also specialize that code by overriding these functions by writing our own, and yet we can still call the code that's within the base class. And this is like a really common pattern. This is really like super common in object-oriented programming in Python.
In terms of syntax, what marks the what defines the scope of the class? Because here, I mean, does it finish at line 7 or is there anything specific?
Spaces and tabulation. So
Okay, so yeah, if it is back to
and there's no rules. So like you could use 1 space, or you could use, I'm using 4 spaces here, or you could use 10 spaces. As long as you keep the same convention, you can indent your code however you want, and the indentation levels basically specify the scope.
Okay.
Cool. So I'll stop recording because that's everything.
Is there any best practice about that?
4 spaces.
Tab.
4 spaces. I would say 4 spaces. The reason why I say this is because if you use tabs, you can actually override your IDE or your editor to display tabs however wide you want them to be. So if you use 4 spaces, your code will end up looking the same everywhere. Whereas if you use tabs, it might end up looking different.
So you've got to manually put the spaces in.
Every line.
Lots of editors actually automatically convert tabs into 4 spaces. Like if you use any decent editor, has that functionality in there. So Sublime has that. So you press tab and it's actually putting 4 spaces.
Okay. So it's just something to know.
Yeah.
So if you're using that Notepad, for example, you
No,
want
that wouldn't do it.
no, you want to be putting your 4 spaces.
You would have to put your
Yeah.
4 spaces, yeah.
And then you can like, cut and paste and stick it into an editor.
Sorry?
And then you can cut and paste and stick it into an editor.
Uh,
And keep that 4 spaces.
My question would be, why using Notepad?
Yeah, I know.
Alright, cheers.